Hey guys, so we're going to talk about section 12.3 tonight, which is inscribed angles. Just so you guys know, this unit is actually going to combine chapters 10 and 12. So it is important that you know the difference between what we did yesterday, which was central angles, and what we're learning tonight, inscribed angles. So let's actually refer back to something I had mentioned yesterday. Let's just talk about chords. If you remember, a chord is a segment on a circle that starts at one end and just travels to the other end. If it were to go through the center, that would be called diameter, but it doesn't have to. So what would happen if we had two chords that met up at an endpoint, such as this example here? This is an inscribed angle. So it's different than a central angle. It's not starting from the center. It's actually starting from a shared endpoint of two chords. So you can have different types of inscribed angles. You can have like a skinny inscribed angle like this one. You could have a larger inscribed angle, such as the second picture. Or you can have an inscribed angle whose endpoints of the angle actually create the diameter of the circle, which we'll talk about. So these are all pictures of inscribed angles. So let me give you guys the definition. An inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. Now yesterday with central angles, we talked about how those angles broke the circles up into two parts. You have your minor arc and then you had your major arc. Well, if you look at all three of these pictures, inscribed angles actually split the circle up into three parts. So we're not going to talk about all three parts. There's only one part that we're going to talk about, and that's known as the intercepted arc. So the intercepted arc is the arc which lies in the interior of the inscribed angle. So if we take a look at the first picture here, I have three arcs to look at, but I only want the one that's lying inside of the angle. So the arc that's lying inside of the angle is going to be that arc there. So it's basically which arc is the angle opening up towards. That is the only arc we're going to really talk about when it comes to inscribed angles. So let's talk about how do you find the measure of those arcs. So yesterday we talked about how when you have a central angle, the measure of the minor arc equals the measure of the angle. This time it's different. The measure of the intercepted arc will equal twice or two times the measure of the inscribed angle. So the arc is always going to be two times bigger than the angle. So you can just remember that phrase, or if you like equations, because that's a way of showing your work as you're solving problems, you can actually remember this equation. The arc equals two times the angle. So let's take a look at example 1 here. So you guys have an inscribed angle, ADB, and we're actually given that inscribed angle is 84 degrees. Knowing that, we're going to find the measure of arc AB. So according to the rule, that arc is going to be 2 times the angle. So you're just going to do 84 times 2, which will give you 168. Now again, if you want to use that formula or the equation, arc equals 2 times angle, just write it out. Plug in what you know. Okay, my arc is AB. It equals 2 times my angle, which we do know is 84. And then you'll end up getting the same answer. Let's take a look at example 2 here. So here I have another inscribed angle, angle WED. We are given the measure of arc WD this time. This is 67 degrees. Knowing that, we're going to find the measure of angle WED. So if we're working backwards, instead of doubling the amount, we are actually going to take half of the amount. So the measure of WED will equal 33.5 degrees. Again, if you're using that equation, plug in what you know. Okay, my arc is 67. I don't know my angle, if you want, you can call it S. But I'm going to take the same exact steps and just divide by 2. So just remember, the arc is always 2 times more than the inscribed angle. All right, let's take a look at one more, example 3. So this time we're given the measure of arc NO. So I'm going to label that here. It's 46 degrees. We're also given the measure of arc OT. That is 112 degrees. And we're trying to find the measure of arc NT. We're trying to find this missing arc here. And we're also trying to find the measure of angle NOT. So which one do you think we should start with? Well, since I've been given 2 arcs around the circle, I should probably use that to find this missing 3rd arc. How do you think we'll do that? Well, what do you guys know about a full circle? It equals 360 degrees. So let's add up the 2 arcs that have been given to us. 112 plus 46 is going to give you 158. And then you're going to subtract that from 360. That will give you 202. So now we know the measure of arc NT is 202. I'm going to list that over here. Measure of arc NT, 202. So now that we know arc NT, how are we going to find the measure of angle NOT? Well, it's an inscribed angle opening up to arc NT. So what do we know about it? It's going to be half. So half of 202 is 101. Okay, example 4. So it says, what is the measure of arc CA and the measure of angle CBA? So let's just start there. So if you see, angle CBA is an inscribed angle, but it's one of those special scenarios that I mentioned in the very first slide, where the endpoints create a diameter. And I know it's the diameter because it's going through the center. So you got to think back to what we talked about yesterday. What does a diameter do to a circle? Well, it splits the circle into 2 semicircles. So this entire part of the circle is half of 360, which we know is going to be 180 degrees. So that is actually the measure of the arc, CA. So now that I have that arc, angle CBA is the inscribed angle that goes with that arc, so it's going to be half of it. So it's half of 180, 90. So anytime you have an inscribed angle that opens up to form a diameter, that inscribed angle will always be 90 degrees because its arc will always be half a circle, which is 180. Now, this gives us a little bit more information. It says, what if angle ACB is 42 degrees? So let's label that. So angle ACB would be this right up here in the corner. We're trying to find arc BC. So how do you think we can find that arc? Well, if you think about what angle opens up to that arc, I actually have a second inscribed angle in this picture. So let me erase my first one. I'll put the 90 and 42 back in there. I have another inscribed angle. Angle CAB. So sometimes you will have more than one inscribed angle in the picture. So this is the angle that's opening up to arc CB. So if we can figure out this missing angle here, then we could figure out the arc because we could just double it. How do you guys think we can figure out that missing angle? Well, we do have a triangle. And what do you guys know about triangles? Those three angles should add to 180. So let's add our 90 with our 42 to get 132. We're going to subtract that from 180, and we're going to get 48. So this inscribed angle is 48 degrees. So now how do you find the arc? You're just going to double it. 48 times 2 is 96 degrees. So that is the measure of arc BC. All right, so this leads us into the next example. Okay, what happens if you do have more than one inscribed angle in your picture? And this happens a lot. So if you take a look at this first picture here, the first thing you should do is highlight, okay, where do you see some inscribed angles? So we're just going to do these one at a time. Look for your chords. Okay, the first chord that catches my eye is RQ. I can see another chord that's connecting to it, especially at R, so that makes an inscribed angle. So I have an inscribed angle over here at QRS. All right, where else do I see some inscribed angles? I'm going to erase that first chord. And I see another chord that connects here at S. So that makes another inscribed angle. So we can call that angle RST. All right, and then I don't see any other chords that are connecting to make a third inscribed angle. So now that I have this information, I'm going to find all these measures. I got 2 missing arcs, and I have, 3 missing arcs and 1 missing angle. What I would do first is just start with your picture, label as much as you can on your own, then go back and we'll fill in the measures. So let's start with that first angle, QRS. If I know that it's 37 degrees, I can easily figure out the intercepted arc that it opens up to. I can figure out QS. I'm just going to double 37. We're going to get 74. All right, let me switch gears and focus on that other inscribed angle. Okay, so I don't know the angle, but you'll notice I do know the arc that it's opening up to at 60. So I'm going to work backwards. If we have the arc, we're going to divide by 2 to get that angle. So this angle is 30 degrees. All right, so let's see if we can start answering some questions here. So let's look at the measure of arc QS. Well, that was the first one we found. That's going to be 74 degrees. Let's look at angle TSR. So TSR is actually that second measurement that we found. That's going to be 30 degrees. Now it's asking us about arc RQ. So when you look at arc RQ, it's the top part of the circle. How do you think we can figure it out? Well, if you haven't noticed, there is a special part drawn on the circle that we mentioned yesterday. R through S goes through the center. So what part of the circle is that? That is a diameter. And what do we know about a diameter? Splits the circle into semicircles. So I know that this entire measure is going to be 180. So if I know that's 180, that's going to help us find our RQ because I can subtract 180 minus 74 that we found earlier. That will give us our missing measurement. So that will be 106. So this RQ is 106. And then you'll notice it's asking us for the very last arc, TS. So there's more than one way to figure this out. You can take a look at all of the individual arcs that we found. We know that they should add up to 360. So you can add up the 60 plus 106 plus 74, subtract from 360. Or you can think about semicircles again, because I could focus on the bottom half of the circle. I know that's going to equal 180. So we can just do 180 minus 60. That's on the left-hand side, which will give us 120. All right, so here's another example where we have more than one inscribed angle. So again, let's just name them first. So I'm going to take a look up here. I have chord. I have another chord. They connect at Y. That is an inscribed angle. So we can call that angle X, Y, W. I'm going to go back to that first chord. I have another chord that connects to it, XZ. So they connect at X. So that is another inscribed angle, Y, X, Z. Okay, let's say I talk about what's going on down here. I can connect this chord with this chord. So I have angle YWZ. I can erase that one. I can connect XZ. That meets with WZ at Z. So again, that's another inscribed angle. So that's XZW. And that should be all of my inscribed angles. All right, so again, we're just going to kind of jump around the circle. Let's find some measurements, and then we'll just fill them in at the very end. So notice how you do not have a diameter in this picture. I know you might be tempted to say, oh, XZ is a diameter, but it's not. The reason why it's not is because you're usually given a center, and there's no center given, and you don't want to assume that it's a diameter. So let's not think 180 at any point during this problem. Let's just start with that, this angle here, YXZ. We know that it's 50 degrees. The intercepted arc that it's opening up to is YZ. So we can just double 50. We can get that this arc's 100. Let's jump around a little bit more. Let's go to this other angle that's labeled 35 degrees for us. So that is angle XYW. So if this angle is 35 degrees, its arc is XW. We can just double 35. The arc is 70. Now, let's talk about the other two angles that we haven't touched on. I'm going to focus on this inscribed angle. We could figure out that angle, because if you notice, this inscribed angle is also opening up to the 100-degree arc. So I actually have two angles that are opening up to the 100-degree arc. I had this 50-degree angle earlier, and now I have this one. So anytime you guys have two angles that open up to the same arc, they're going to have the same measurement, because I'm going to take half of 100, and that gives us 50. So this angle right here is going to be 50 degrees as well. Now let's say I wanted to look at that other angle. So the last angle that we had listed was XZW. Well, again, if I wanted to figure out this angle, it's opening up to the arc XW, which we knew earlier was 70 because we got it from this 35-degree angle. So again, I'm just going to take half of 70, and that's going to give me that this angle is 35 degrees. So we actually have two equal triangles inside of this circle. We don't have to figure these out, but if we wanted to figure these vertical angles out, we could. But I don't think the question is going to ask us that. Okay, so let's fill in the blanks. So the measure of arc YZ was 100. Measure of arc XW was 70. And then the measure of these angles YWZ was 50. And then XZW was 35. Okay, so here's basically just a brief explanation of what we just did. So this says angle ADB is congruent to angle blank. So as you can see, it's already drawn here, angle ACB, because they have shared arcs. I'm sorry, they have the same angle markings. So since they are congruent angles, and they do share arc AB, we can say, so their intercepted arc AB will be the same. So I'm just making up a number. If this arc's 80 degrees, what are each of those angles going to be? 40. Okay, so now we're just going to talk about inscribed polygons. So an inscribed polygon is when inscribed angles make a polygon. So a polygon is just any shape, a triangle above. And all vertices lie on the circle. So typically the one polygon that we use the most are quadrilaterals. So let's just say I have one inscribed angle that connects to another inscribed angle that connects to one more inscribed angle. This is actually a pentagon, 1, 2, 3, 4, 5. But we're going to work mostly with quadrilaterals, which we'll get to. The circumscribed circle is just the name of the circle that contains an inscribed polygon. So this is the circle that contains these vertices. But we're going to talk about an inscribed quadrilateral. So I'm going to have you guys sketch this out. So just draw a circle. Here's the center. And I'm going to have you guys draw 4 inscribed angles that are all going to connect. And now you have an inscribed quadrilateral. And the most important rule that I need you guys to remember, because we're going to use this a lot in this chapter, is that opposite angles of these inscribed quadrilaterals are supplementary, which means they're going to add to 180. So if I were to just quickly name these angles, I'll just use letters. We'll call them A, B, C, D. Opposite angles. So angle A and angle C are opposite. They're going to end up adding to 180. And then angle D and angle B are also opposite. They're also going to add to 180. So it's a little bit different than chapter 6 when we talked about parallelograms, because this is not a parallelogram. You clearly see this is just a random four-sided shape. Opposite angles are not going to be equal. They're going to add to 180. So let's use that for the next two examples here. So for example 1, I have an inscribed quadrilateral, and we're going to find the values of x and y. So all you have to do is look for some opposite angles. So if I start with angle K, 3y, what's its opposite angle? It's F, which is also a 3y. So according to the rule, I'm going to add them up to 180. So we're going to have 6y equals 180. We're going to divide by 30. So now we can take a look at the other opposite angles, which will be an 8x and a 4x. Those are also going to add to 180. You're going to get 12x equals 180. Divide that, and you're going to get 15. Okay, and then let's look at example 2. So the goal is to find the measure of arc DCB. So I'm just going to trace that here. But before we do that, let's actually use this whole opposite angle idea to help us get there. So if I were to try to figure out angle A, what's its opposite angle? It's going to be 35. So what's 180 minus 35? That's going to be 145. All right, let's say I want to find angle B. Its opposite side is 55. So 180 minus 55 is 125. Now, if you just want to check that your answers make sense, what can you do with all 4 of these angles? You can add them up, and what are they supposed to be equal to? 360, because that's what we learned in chapter 6. 4 angles inside of a quadrilateral at 360. All right, so now that I have all these angles, that's going to help us find arc DCB. I just have to think about which of these inscribed angles, A, B, C, or D, is opening up to arc DCB. So if I were just to take the endpoints of arc DCB, there's only one angle that opens up to it. Angle A, which is 145. So if I know this angle is 145, how do I find its arc? We're going to double it. 145 times 2 is 290. So that is the measure of the arc. All right, so if you're really comfortable with the difference between inscribed angles or central angles, you can skip this next part. This is just going to be a little bit of an overview. But it might be helpful just to take a look at it and quiz yourself. So for the first picture, I have angle CAB, and we're trying to figure out, is this a central or is this an inscribed angle? Well, you'll notice that the vertex of the angle is on the center. So this is definitely a central angle. Now we're given that arc BDC is 290. So if all of this is 290, and we want to find angle CAB, how do we do that? We got to think back to yesterday's notes. The major arc, if you subtract that from 360, will give you the minor arc. So this minor arc is 70. How does that help us find the angle? It's not going to be half. It's going to be equal to it. So that angle will also be 70. If you take a look at this second picture, I have angle ABC. You'll notice that its vertex is on the circle, and its sides are made up of chords. So this is going to be an inscribed angle. And if we're given that the measure of arc AC is 108, if I want to find that angle, what do? We're going to take half of it. So 108 divided by 2 is 54 degrees. Let's take a look at this last one. the heck is going on here with angle DOG? So if I look at the vertex, which is O, it's not on the center, because that would be A. It's not on the actual circle, because it would be over here somewhere. So this is actually neither a central or inscribed angle. Well, but let's look at what they gave us. They still gave us the measure of arc DG. This is 165. What else can we conclude about the circle? Well, I can't figure out the angle because I don't know anything about it. It's not a central or an inscribed. But we could talk about the rest of the circle's arc. So how much is a full circle? 360. So I know that we can subtract 165 from 360. We can at least get that remaining arc, 195. So we can say the measure of arc DSG equals 195. All right, so here's an example where we actually have an inscribed angle and a central angle in one problem. This is going to be something that you're going to see often. So let's go ahead and name the inscribed angle. So remember, the inscribed angle is made up of chords. So take a look at where you see chords. I see one chord here from C to B. I see another chord here from A to B. Since they meet at B, that's your inscribed angle. So we're going to call it angle ABC. And it says name the central angle. So always look for the center of the circle, which is at O, and then find the angle that's opening up from O. So that would be angle AOC. Now we need to find the measure of this angle, AOC. Well, let's start with the inscribed angle, since they give us that angle 60. So if this angle is 60, let's talk about the arc that it's opening up to. Arc AC. If the angle is 60, how do you find the arc? You double it. So now that I know this arc is 120, how does that help me find my central angle? Well, the central angle is also opening up to this arc. And what we learned yesterday about central angles, they're going to have the same exact measurement. So this angle will also be 120. Okay, the last type of angle that I'm going to teach you about is called the CT angle. There's really not a name for it, so we just kind of made this up. It's an angle that's created by a chord and a tangent. So this says if a tangent and a chord intersect on the circle, let's actually just stop there. If you don't know what a tangent is, I'm going to draw one for you. A tangent is just a line that's passing through space, touches the circle at one spot, and then keeps on going. I kind of think of it as a hit and run. Imagine like you're driving in your car, you hit something and you run. Don't do that, but that's basically what a tangent is. Now a chord is a chord, starts at one spot on the circle, goes to another spot on the circle. So let's say I have these two segments, or a line and a segment, and they end up intersecting on the circle. So here they're intersecting at this point. Then the measure of the intersected arc, meaning the part of the circle that this angle is opening up to, so that would be right here, is twice the measure of the angle. So it's pretty much the same exact thing as an inscribed angle. So I'm just going to make something up. If, let's say, this arc is 200 degrees, then this angle is going to be 100 degrees. So we're just going to use that for the next two examples. These will be pretty quick. So for example 1, we're going to solve for W. So let's just take a look at what's going on. We've got a tangent line, passes through the circle here. I've got a chord. Okay, they're meeting right here at W. W is the angle that they create. We are given that this arc is 246. So if I know the arc, how do I find the angle? I'm going to take half of it. So angle W is 123. Okay, and then we got this last one here. So we're going to find the measure of angle BCQ. Let's just first kind of analyze what's going on. So I have a tangent line passing by the circle, hits it at C. I actually have two tangents here. I have one, AC, that's actually a diameter, and I have the other one, BC. So the goal is to find angle BCQ. So let me highlight that in blue. Okay, BCQ. So I'm really only concerned with this angle here. And it's a good idea to figure out, okay, where's the arc that goes with that angle? So I just need to figure out this arc. If I can figure out that arc, then I can definitely figure out our missing angle in blue. So right now I just need to ask myself, okay, how can I find that missing arc? So if you look at the picture, there is a 25 degree that's been given to us. That is going to help us, because that 25 degree is part of an inscribed angle. So you'll notice that inscribed angle also opens up to arc BC. So if the angle is 25, how do we find the arc? We're going to double it. So this arc is now 50 degrees. Now that I know the arc is 50 degrees, I can find that missing angle that we're looking for, created by the tangent and the chord. We're going to take half of it. So this is going to be 25 degrees. Okay, that's it for tonight's lesson. Thanks for watching, guys. Let me know if you have questions. Feel free to text me on Remind, or you can also email me. All right, have a good night.